So here are our culprits again that we've seen a couple times, the inshore rockfish species. In case you've forgotten about them, I'm going to give you another little recap about them because it's been a few hours. I want to drill in their life history characteristics that are really of importance in this context. So these 6 species were managed together as a complex called the inshore rockfish. Go back up on the top here, yellow eye, copper, tiger rockfish, china, and black rockfish in the bottom. These species live on shallow rocky reefs from just the nearshore subtidal down to about 200 meters in depth. And they're distributed in different depths. The species are distributed throughout different depths. So copper and black, like Jeff was telling us, are up shallower. Yellow eye are typically found quite deep, and it's not as common for scuba divers to come across, particularly the adults of these. Quillback rockfish, which is one of the other main species that I've studied, are found up in the scuba diving ranges, but their main center of abundance is actually quite a bit deeper than most divers can get to, and their highest abundance is around 90 to 100 meters. They're also extremely lonely. We've heard this a few times. Even when Jeff said, oh, these copper and black rockfish, they don't get to be that old. In comparison to what a lot of people think about salmon, they're very old. They live to be about 50 years of age. So from a rockfish perspective, that's pretty young because these guys live to be 90. Yellow eye have been aged to over 120 years in British Columbia. So a 50-year-old fish is still quite a lot older than a 4-year-old salmon or even a 10-year-old herring. Lily told us that they've got closed gas bladders. This means that when you pull them up from depth, the gas that's contained in their gas bladder expands and causes what we call barotrauma. The barotrauma manifests often in having their stomach pushed right out through their mouths, their eyes often bug out. This is all the gases that are in their bodies have expanded. This is one of the main reasons why the rockfish conservation areas are so important, because catch and release strategies that work for a lot of species such as salmon and trout and a lot of the other really prime game fish that people are going for is really not an effective strategy for these guys. Lily also showed this map. So as a result of these really steep declines that happened throughout the 1990s in the catches after the major development of fisheries earlier on in the time series, Fisheries and Oceans Canada announced a conservation strategy. This was announced in 2001, and it had 4 main points to it. The first was to start accounting for all catches, including discards. The second was to reduce the directed catch, and they drastically cut the total allowable catch for the commercial fishery, as well as reduced the bag limits quite severely for recreational fishing. They also brought about a system to improve self-assessment monitoring. And then what I've mostly been interested in is they designated areas closed to fishing, which we've come to call Rockfish Conservation Areas. They designated 164 RCAs throughout the coast of British Columbia, which is a pretty impressive management action to have taken on. Of those 164, 144 are seen here in the south coast, and all of my research focused on the south coast. The north coast being so much farther to get to and more difficult to get to, as Lily's nodding her head going, oh yeah, I've worked in the Central Coast. Anyway, I limited my scope to this, but that is where the bulk of the RCAs are. So for my dissertation, I studied 4 main projects and produced 4 main data chapters. I'm only going to tell you about 3 of them, although as Jeff was talking, where is Jeff?
He left.
Oh, he's already heard me. Okay, good. Well, I don't feel as badly because I wanted to tell him about my last chapter. He came to my dissertation defense, which is basically the same talk. And I was like, oh, I missed an opportunity to tell Jeff about this again, because this has to do with that 2006 black rockfish year class. So anyway, don't need to worry about that. First, I'll be telling you about surveys that I did using a remotely operated vehicle These were done in conjunction with NACA at DFO. Next, I'll tell you about my work on recreational compliance in the RCAs. And lastly, I'll tell you about the way I tried to evaluate all of the RCAs in the South Coast using a conservation score and a habitat model. So we'll start with the ROV videos. Our ROV video data, and again, this was work that Lin Yam Naka, the Pacific Biological Station, was really instrumental in getting off the ground. So the main question with this work is whether or not there's any evidence of increased fish densities in the RCAs. And we thought that if there was any differences inside to outside of RCAs, that would largely be on targeted species, and not species that are not fished by fisheries, either recreational or commercial. We also thought that the age of the RCA might influence their effectiveness. And we started sampling these quite soon after they were put into place. Our surveys went over a few years, and so depending on when the RCAs went into place and when we did the surveys, the RCAs were between 3 and 7 years of age when we sampled them, or had been in place for 3 to 7 years. And I also wondered if the level of fishing pressure that was adjacent to the RCAs would influence whether there were more fish in or outside of the RCAs. So we did our surveys on these two Canadian Coast Guard vessels, the Neocalagus and the Vector. They were large ships, so that meant we were limited by depth as to how shallow we could survey. So this is the opposite from the scuba surveys, where your maximum depth is about 20 meters or 60 feet. Our shallowest depth was about 20 meters or 60 feet because the captains running these big ships started to get really nervous when they didn't have as much draft underneath them. And be like, okay, Dana, that's it. We're not going any closer to shore. The ROV that we used is this yellow thing up here. It's a Phantom 5 ROV. It's got a long tether attached to it, which is seen in here. The tether has the means to control the ROV and capture the video. And then we would set up in the lab with oodles and oodles of computers and recording systems and tracking systems, and yeah, to definitely take over the lab with all of our technical tools. We did 5 different surveys all around Vancouver Island, and some of those were quite close by here. If you look at this panel here, we did survey the Salt Spring and Trincomalee Channel, and then Prevost Island, and up here Valdez Island. Because we didn't have any data from before the RCAs went into place, we used a control impact design. So we would plan surveys, transit lines inside and outside of the RCA so that we'd be able to compare if there was any difference between the RCA and open areas. This transect is, I think this one right here on Valdez Island, which I pulled out, and I remembered it being a nice and fishy transect. So I thought I would just blow that up to show you a little bit of what the data that we collected ended up looking like. Once we went through and had people apply, spend about 5 hours for every hour of videotape. That's about the amount of time it would take people to watch the video and actually get the data from off of the videotape into a database. And then we also had people working on tracking them and mapping it all out. So I was lucky and I got the data in more or less in this format. So we would collect habitat information along the transect. So these are divided and colored in rock, mixed, and soft habitat. And we could put fish on top of them. And this was a pretty typical observation that we would see, that in areas where it was rock, we saw kohlback and lingcod, typically over in the shallower area. This area is mixed. There's some kelp greenling here. This is a flatter area. There's some flatfish and green striped rockfish, which are typically, they're opposite from a lot of rockfish, and they're in softer habitats quite often. Then we get back into some more mixed stuff. There's probably a few boulders around there. There's some kohlback. Another soft area, there's ratfish seen, and a yellow eye up there, another nice patch of rocks that we saw.
Sorry, Dana, are each of those points one fish?
They can be more than one.
Can be
I didn't Well, typically they're one, but sometimes there were groups. And Andy, just because I know you'll probably be wondering about all of these pink dots and the pygmy snailfish,
Oh, yeah.
I believe that's actually incorrect. That was a typo in the database, and I forgot to fix it. It's been fixed in the master database and not in the one I drew from. We ended up doing 364 transects. 199 were in the RCAs, and 164 were outside of them. Quillback were our most frequently observed rockfish. And yeah, that picture there is up off of Entrance Island, so relatively close to here. So when I went to analyze the data, I looked at whether or not there were differences for quillback, yellow-eye, inshore rockfish as a combined group, lingcod, kelp greenling, and green striped rockfish. And I ran each of the my analyses separately for those species or species groups. And I used a modeling technique to try and get at the questions as to whether or not there was more fish inside or outside of the RCA. Because rockfish are really, really dependent on rocky habitats, thus their names, I needed to control for habitat variables. So the habitat variables that we collected along those transect lines also were used in my model. And what I ended up finding is that fish density was related to habitat variables and the depth that they were found at, but that the level of protection, so whether they were inside or outside of the RCA, was not significant. In the scientific literature, it's really common when you're looking at marine protected area papers to see this same kind of design, or the same kind of data displayed as what's called the response ratio. And what a response ratio is the ratio of fish seen inside to outside of an RCA or an MPA, or whatever treatment you're looking at. It's nice because if you have a positive value, that means there's more fish in your protected area. If you've got a negative value, there's fewer fish inside your area, more fish outside. If it's 0, then there's no difference between the two treatments. So I calculated this response ratio for all of my species in question and all of the RCAs. And once I accounted for habitat differences that were seen along the transects, most of the response ratios were not terribly different from 0. And so when I looked at whether there was a difference between the targeted or the non-targeted species, so kelp greenling and green stripe are taken as an aside, but not usually targeted by fisheries. So they are my non-targeted species, and there was no differences here for any of the groups. I did some other work to see whether the age or the size of the perimeter to area ratio or the level of commercial catch that was adjacent to the RCAs were driving the response ratios that I did see, and none of those models were significant, so I wasn't left with anything. I was a little disappointed in this because I thought, in addition to establishing the RCAs, another major action was that the commercial catch and the recreational catches were really curtailed. Those catches were cut significantly. So in a lot of the areas that I sampled, there was actually no commercial fishing outside either. So you're like, well, am I really trying to test whether or not there's an effect of these RCAs if really that RCA is probably actually a lot larger if there's no commercial fishing that's going on outside any longer. So I was surprised that there wasn't anything with the commercial catch. The age, I also hoped that the older ones would be starting to show trends, and I was disappointed that wasn't the case. But we also had a bit of a spatial correlation with the age. So I concluded that fish density is dependent on habitat and depth, but that there's no evidence of increased densities in most of the RCAs. It is really important to account for the habitat that's surveyed. Otherwise, it's something that you could be attributing to an effect of protection is really just an effect of the habitat. The commercial effort, as I mentioned, is still quite low outside many of the RCAs. And so that may be one of the reasons why it's difficult to see any trend in the data. Basically, the populations are not continuing to drop outside either. The RCAs are still very, very young, particularly with respect to the age of a rockfish. Remember, I've told you that quillback and yelloweye live to be close to 100 or over 100. So it's likely, and they don't start reproducing until they're in their mid-teens, as Jeff told us as well. So it's going to take a while for these populations to recover. So the next chapter that I'll tell you about is work that I did on recreational compliance. This was a fishing boat. It's difficult to see the sunshine again, but there's a sport fish boat down here. When we were up in Chequasit Bay on the west coast of Vancouver Island, doing our ROV surveys, at one point the bridge called down and said, "Hey, there's a boat fishing in the RCA. Do you want to go over and talk to them?" So we went over and chatted to them and asked, "Did you know that you're fishing in an RCA?" "Oh, well, we thought you were allowed to halibut fish in these. The people at the lodge down in Cayucot said you could come up here and halibut fish as long as we weren't rockfish fishing." I said, "Okay, well, we did some education with them." This observation is not unique. Anyone who spends time on the water or around the water, looking out from Galiano Island here, has seen observations of people fishing in the RCAs. Jeff from the aquarium, who spoke earlier, has even gone as far to say that the RCAs have become a roadmap of where to go fishing. So before I started this project, this issue hadn't yet been looked at. We do know that there's very good commercial compliance on the other side, because the commercial fishery has 100% either onboard or electronic monitoring in their fishery. So we know where they're fishing and have good evidence there's good commercial compliance. The RCAs are not complete no-take areas. Recreational and commercial fishing with hook and lines is not allowed, and commercial bottom trawling is also prohibited. So what they tried to do in coming up with the fisheries that were and aren't allowed in the RCAs is to not allow any fishery that either targets or leads to high proportions of bycatch of rockfish. So a number of fisheries are still allowed to go on in them, including shrimp and prawning by trap and crab trapping, and a number of commercial fisheries that don't have heavy levels of bycatch. However, what I wanted to point out here is that this is the DFO website. This is the information that you get if you go to their website on what you can and can't do in the RCAs. And somebody who is probably very well versed in communication said, "We should phrase this in a positive framework because people don't like to be told what they can't do." But down here, they say fishing activity is not listed above, is restricted. And I'll mention I added the emphasis of the red box on this. And it's very confusing for someone to go to this and say, "Oh, actually, I can't salmon fish in these." Eddie?
Could I just make one point for people
Yep.
who have a background? The last point there, it says, one of the permitted activities is ground fish by mid-water trawl. And by definition, rockfish are ground fish in that group. So as long as you're a rockfish and you're hiding on the bottom, you're okay. But if you stick your head up too far, in theory, I don't know whether it happens, in theory, you could be a rockfish whistled out of that.
Yeah, it's mostly, the midwater trawls are mostly targeting walleye pollock and a little bit of Pacific cod, but the other fish that they do target is yellowtail and widow rockfish, which are not the inshore rockfish suite, so I think that's why they thought they could go on. And I actually haven't looked at the midwater trawl data to see how much of that has gone on in the RCAs.
So, why is it they don't exist? Like, it is kind of confusing when you look at it, but they're not willing to also put a list of what you can't.
They haven't in the past. Darian and I were at a meeting a couple weeks ago when we raised this issue with them, and the communications people in the room were even like, "Oh yeah, I guess that doesn't really make sense, and we should clarify this." But it takes forever to update government websites because you have to go through a whole process and basically get permission from the Queen or something. But anyway. So what I wanted to ask in this work is whether or not recreational effort changed in response to establishing the Rockfish Conservation Areas. My next question was what factors influence whether or not an RCA is likely to have good compliance or not. Fisheries and Oceans, or what we call DFO, manages the recreational fishery using a creel survey. And for those of you not familiar, a creel is like a basket that you put your fish catch into. So that's why it's called a creel survey, because in the most basic form of a creel survey, a fishery person would come up to someone who's just fished and say, hey, what's in your creel, what's in your basket? So the creel survey has two components to it. One is dockside interviews, where exactly this, they walk up to fishermen and say, what did you catch? How long did you fish for? Where were you fishing? What did you release? Next, in addition to that, they do overflights where they count the boats. They combine these two pieces of information to come up with an area-based estimate of sport fish effort and an estimate of catch. And when they do this, they apply it to an entire area. And so this map is one that's similar to what Lily showed earlier. This is showing the RCAs around Vancouver Island, and those that are visible from the flight paths, as well as some are not visible. But 105 of the 144 RCAs in the south coast here are visible from the aerial survey paths. 77 RCAs are in the Strait of Georgia. And then up in the corner there, you see the airplane and the observer that's making the observations on the survey. So I got to go on one of the surveys in the northern Strait of Georgia on a really sunny, beautiful, calm day, which was very nice. So I mentioned that typically DFO will apply their catch estimates to an entire management area, such as these ones. However, a friend of mine who works with these data clued me into the fact that if you go back to the original data sheets that observer sitting in the airplane had, though there's much finer scale information on them, such as 3 people fishing here, 1 person fishing here, 1 here, 3 here. So I went back and I scanned and georeferenced over 2,000 images and digitized over 65,000 fishing observations. Luckily, I had 3 GIS technicians to help me with this. I did 2011 all on my own, and then had people help for it with 2003 and 2007. It was a lot of work, though. This was going to be a small little side project, and it snowballed into its own entity. When we digitized it, we didn't display the RCAs so that we wouldn't be biased to either place an observation inside or outside of any RCA.
One of the dots here was fishing and not fishing.
Oh, yeah.
How do you tell that?
So the observer that's up there, he's holding a pair of binoculars in his hand.
Okay.
And he actually looks at every boat. If he can see fishing lines in the water, it gets coded as fishing. If he doesn't see lines in the water, then it's either it's not fishing, which is either deploying traps or traveling between sites. Yeah, that's a good question. So in order to answer the question whether or not effort had changed, I looked at data from the Strait of Georgia. I wasn't able to get data from before the RCAs went into place for around Vancouver Island. But within the Strait of Georgia, I had data from 2003, which was the year right before the RCAs started to be put into place, and 2007, which was the first year after all of the RCAs had gone into place. And there had been a little bit of outreach and education from the Fisheries and Oceans. And then 2011, which was the most recent year when I started this project, so you can get a sense of how long I've been working on this. I standardized the monthly effort for the type of day, either weekend or weekday, because more people fish on weekends than they do on weekdays, and the number of surveys that were completed by month. And then I compared the effort in the RCAs as well as effort around each of the RCAs in a 1 kilometer buffer strip around it, which I was trying to use as a bit of a control. And what I basically found is that, so that there's 3 things here in this graph. The black bars are the effort, mean effort, or this line is the median, but the effort inside the RCA versus outside, the buffer around it. So one result was that the effort was greater outside of the RCA than inside in all 3 years. The next is that there's a declining trend, but that the declining trend was mostly outside of the RCAs and not inside the RCA. And so this means that I couldn't take any declining effort to be as a result of putting the RCAs into place, but it was probably as a result of economic situation or Chinook catches or things of that nature.
Yeah, sorry, what is effort?
Effort is, sorry, that was what I measured. So this is the number of boats that are seen inside the RCA or in the buffers area in that standardized way. Yep.
What are your air bars?
The error bars, these are box plots that are, the error bars are the 75%, 25 and 75% confidence. And that's on a log scale. I also looked at the effort in individual RCAs. And overall, I found that effort in 83% of the RCAs had not changed. However, 18% of those had no effort in any time period. So it's not that they were all 83% of those had been fished. Effort increased in 5 RCAs, and effort declined in only 8 RCAs in either 1 or both years. And so what this map is colored by increases in effort are shown in red. Ideally, we want to see a lot of blue going on, because the blue is a decreased effort, such as here at middle match. And then these middle colors are showing there's no effort in any time period, and these orange colors are showing that there is effort in all 3 time periods. So I also had digitized data from around Vancouver Island for 2011. So using the 2011 data, I asked the question, what factors influence effort? And I did a modeling exercise where I looked at the amount of effort in the region around it using a 2-kilometer area buffer around each of the RCAs, the distance between any RCA and fishing lodges, as well as an RCA and cities, the human population within 25 kilometers of an area, the size and shape of the RCAs, the area perimeter boundary, as well as the amount of enforcement in the region and the level of rockfish catch that was estimated in the creel survey. I put this all into a nonlinear modeling environment and found that the significant variables which were retained in the model were the amount of fishing effort adjacent to the RCA, the size of the RCA, with bigger RCAs being more at risk of being fished, enforcement, and the perimeter to area ratio, and the distance to fishing lodges, with RCAs between 15 to 20 kilometers, or under 15 to 20 kilometers away, having greater risk of being fished. Taken together, these all suggest to me ignorance over directed poaching. The proximity to fishing lodges suggests that targeted outreach or enforcement could be an effective strategy. The level of enforcement was significant in the model, but it was really difficult to understand what was going on. But it basically was that in areas where there was the highest compliance, there was also the highest enforcement, such as around Victoria, and areas with the lowest compliance had almost no enforcement whatsoever. The general conclusions from this work is that much more education and awareness is needed about the RCAs. People are confused about what they can and can't do them. They're confused about where they are. They don't know if they're in them at the moment. And we think electronic tools such as smartphone apps could really be used to help educate fishers about where they are. And generally improved communications would be important, which is one of the reasons why it's so nice to be working with the Conservancy on this. We also need to improve and target enforcement and continue monitoring compliance. My last chapter looked at how the RCA is scored overall. It was an attempt to try and figure out, okay, I've studied these few areas, what's the big picture? I drew heavily from a couple papers that came out, this one in particular came out in 2014. And they came up with 5 features that successful marine protected areas had globally. They drew pretty heavily on the other work. So the 5 features that were found in the Edgar paper was the level of protection, with no-take areas being more successful. Successful areas need to be well enforced, they need to be old, they need to be large, and the habitats within them need to be isolated from other barriers so that the fish aren't simply going to swim out of the protected areas to be caught. They called this isolated. The other paper that this work was built on looked at similar features, but they also looked at connectivity between protected areas, and they developed a scoring system and a weighted index. So I decided I wanted to look at these features identified in these two studies and come up with something similar. However, what I needed to do first was to be able to get a measure of habitat, because rockfish are so tied to habitat, and my previous work had shown this. Fisheries and Oceans Canada had developed a habitat model when they set aside the RCAs. And this is shown in this green, the green. However, it's been highly criticized as having overestimated rockfish habitat. And what I did here is I overlaid two of the models that I built with finer resolution data on top of this to show that it probably did overestimate areas. And I'm going to skip through most of these because you don't want to hear about any of the details of the habitat model. If you do, please come and talk to me. I'd be happy to talk to you about it. And Lily, I'm looking at you. I want to know. I used a type of modeling called random forest models. Random forests are used in Google searches. That's their big claim to fame. It's a machine learning method. And what I did is I predicted whether or not substrate were likely to be rock or not rock. And I did this at various resolutions. And my models came up as either being outstanding or of excellent predictive capability. Using this, I finally was able to measure habitat in the RCAs. And so I scored each of the RCAs for these three features: the total area, that percent habitat, and the isolation, this concept of whether or not the habitat was contained within the RCA, such as this one, or if it was leaking out, such as these ones. I combined the scores for those features with RCA size, scores for compliance, connectivity, and bycatch in the prime fishery. I scored each of these from 1 to 3, or bad to good, and then added each of the scores together. And I'm actually going to skip over these because they're dancing around at the back there. So, this is an example of connectivity, and you can see blue is good, blue is a 3, so most of the RCAs are likely to be very well connected. Prawn, bycatch in the prawn fishery, there's a lot of blue again. The prawn fishery doesn't happen in most RCAs, but in some RCAs it's quite high. I added together all of those features. My mean score was 18.6, and this map shows if it's red on here, then it's a low scoring RCA. Up higher is the blues. Next, I compared my conservation score to the response ratio that I had for any of the RCAs where I'd actually sampled with an ROV or a scuba survey, and I found a significant relationship with the quillback response ratio. So I think that there's something with the conservation score that's showing whether or not they're likely to be effective. And the score can be applied to RCAs I didn't sample. This is the table that I will share with the Conservancy afterwards. And actually, looking at the information on the back there, I missed a few of the RCAs in the Southern Gulf Islands. I was going from memory, trying to remember the names of the ones that are in here. But you can see that some of the RCAs close to here, Galiano and Trincomalee, scored quite low. And the data are available to show which features contribute to that low score. So, for instance, Trincomalee here has sort of average habitat. It's a large RCA, so it's got a low percentage of habitat. Isolation is low. Compliance for commercial is high. Low recreational compliance. It's got medium bycatch, and it's well connected for an overall score of 15. So I'll share that with the Conservancy and anyone else who thinks that it'll be useful. So my conclusions from this is that habitat in some of the RCAs is limited. The habitat crosses the boundaries in some RCAs and may lead to high levels of spillover of the fishes that we're actually trying to protect. and the cumulative effects of low habitat, continued fishing, and bycatch in the prawn fishery may reduce the potential of some RCAs. Other RCAs scored really well and are likely to be very effective. This quote was something that I really tried to focus on throughout my dissertation work. They said that now that networks of reserves have been implemented, we need to implement adaptive management. And this means we need to stop simply asking, do reserve work, and get at when and why they work. How long does it take, and what should we be measuring? So usually at the end of my talk, people ask, so do the RCAs work? And the answer to this is that, again, there's a lot of really positive features. This is a gravid female yellow-eye rockfish that we saw in the Desolation Sound RCA. We saw some wonderful habitat in RCAs and our ROV surveys. We saw juvenile fish. But I've also raised a lot of issues along with the RCAs. The best way to address our uncertainty in the design of RCAs and marine protected areas is through adaptive management. And adaptive management in the context of the RCAs can be increasing awareness and enforcement about their regulations and where they are, altering regulations, changing boundaries, or tweaking boundaries even, and continuing to research. And with that, I will say thank you and ask for any questions.